Good morning, Tuesday morning, a rare and special bonus episode of the Coding Train. My name is something like rhymes with fan, something like that. I'm here, I'm saying a bonus episode. It's not really a bonus episode, it's a little bit of a makeup episode. I am trying to make a commitment to doing a live stream per week, one per week. That's about 4 per month. And I have missed a couple in the last couple months, just actually schedule-wise and being sick and that sort of thing. So today is a bonus one. I hope, if all goes according to plan, I will be doing a bonus live stream on Thursday and then a regular live stream on Friday. So 3 live streams in 1 week, that certainly is a record for me. So I would like to know just briefly, if you are a patron and in the Slack group, if you could just let me know the audio and the video and everything's fine. That's something I like to hear. And while I'm waiting for that, I'm going to talk about what I'm going to do today. So today, I've been working very hard on being prepared, which means I opened up some URLs in advance. And this is currently my list for today. So I'm going to be here for about 2 hours. I want to look at WebGL, which is 3D in p5.js. I want to do a coding challenge. A wonderful computational artist, beesandbombs, creates amazing GIFs all the time. Oh, actually, this is simpler than I thought looking at this now. Or maybe it's not. Anyway, this is a beautiful oscillating pattern in 3D. And I thought as a coding challenge, I would try to recreate this in p5.js. I know Alka, one of the viewers, Alka, has actually already done this. So I did not look at Alka's code pen in advance, but I will maybe pull that up later today if someone can help me remember. So the things that I need to cover in order to be able to do this are the basics of WebGL, 3D and p5.js, and simple harmonic motion, which is the swinging of a pendulum, the pluck of a guitar string, this nice smooth breathe in, breathe out, breathe in, breathe out. So, so that's my plan. So that's what I've got on my list today, if I look back here. And on Thursday, I would like to cover something called Word2Vec. I'm going to do some data science stuff. And so some functions that I want to use for that are the JavaScript array functions map, fill, and reduce. I probably won't get to this today, but that is on my list. If I can get to it, I will also do a tutorial about that. Now, a couple things to mention before I get started with some actual coding stuff, which, as anybody who's ever watched one of my live streams before, I kind of take a while to get started. So go out, go for a quick jog, maybe 10 minutes a mile, 2 or 3 miles, jog, have a cup of tea, do some 5-minute meditation, come back, I'll probably still be just rambling on, and maybe about ready to start with some coding stuff. But I do want to, 2 things I want to say. One is for all those of you who subscribe to my Patreon, I know there have been a lot of, there's been a little bit of controversy, I guess might be a word that you could assign to it, and a lot of confusion certainly around some of the new fee structures that Patreon published last week. I'm kind of in a holding pattern here. I'm going to wait to see what they publish about that this week before I make any firm decisions. But it's my opinion that Patreon should not increase the total amount of the pledge, whether it's fees or the pledge, without an explicit opt-in from the user. So depending on what happens, I may just sort of suspend payments for this month and think about what I'm doing going forward. But I just wanted to mention that if you have any feedback about that or thoughts about that, please maybe tweet me at Schiffman would be the best place. Okay, so there's that. Then we got to talk about some random number stuff. So who was it? Somebody in the patron group in this, let me try to find here, pointed this out to me. It was Topher J. Topher J in the patron group pointed out to me a recent episode of The Tonight Show with Jimmy Fallon. So I have that here for you. I don't know how recent this is actually. Oh, it's not recent at all. Oh my God. Oh well. So much for my brilliant but I didn't even look at the date of this. I was thinking, and I'm pretty sure I was not doing this prior to March 17, 2015. Someone just sent this to me, and I just assumed, without looking at it very carefully, that this was very recent. Let's watch it.
Real page turner. This one, I've read it twice, and it's still bad. This is, of course, A Small Book of Random Numbers by James McNally. It's literally just a book filled with random numbers. I mean, and this is helpful here.
This
near
is
the end, there's a bunch
big
of,
book of random numbers.
There's a bunch of blank pages labeled notes, in case you had any notes. You might inspire a number in your head.
Don't think about it.
Don't think about it.
Oh, I don't have any
Give me a
notes
random
in this
number. Give me a
book.
random. Give me a random.
7.
It's in here. Sorry, buddy. That's not as random as much. Yeah, look, it's right here.
Let's see if we can find any that match.
You got me.
Yeah. This is. You know what this is good for?
What's that?
I put my kids to sleep.
Oh.
Yeah. Okay, girls. Not too bad.
But maybe I actually saw this.
I was gonna read from your
Since
favorite.
this actually happened in 2015.
Random numbers. 98768. 22696.
83,343.
2.
28,611.
They're already sleeping.
Wake up!
All right,
She's
so
on right after the jinx.
yeah, I thought maybe somebody was. Whoa, I lost that page. You know, just a little similar.
As I sometimes am on the internet, to read to you from my favorite storybook.
I don't even need to read it.
Random digits.
I could just have myself
You would
read
like
it.
to lie down and close your eyes and
This
fall
is
asleep.
very
You should
strange.
feel free.
I'm a little bit
Guy
bigger
last
there.
left off.
I may need
on
to
page 2.
grow.
77,513. 3,820.
What page is that? What's at the beginning?
86,864. 29,900.
Let's see if I can follow along.
68,414. 82,774.
All right, so anyway.
Next.
Yeah, right? Which is me live right now and which
Okay.
is me from before? All right.
Yes. All right.
All right, never mind. This whole shtick all planned. This work, I stayed up all night, couldn't think of way to get this whole plan, elaborate plan. Jimmy Fallon, coding train, random numbers, musical number, dancing, singing. It was going to be a wild extravaganza, but I guess I didn't look carefully enough. This is from almost 2 entire years later. Okay. So that's that. Let's get off of Twitter here. Twitter's a terrible, terrible place. It is a Tuesday. All right. So let me think. How are we going to get started here? Do I have other things to talk about that are important? I don't think so. I should read some. Here's the thing. I don't remember. I had this thing where I was going to actually try to read the whole book. And I don't remember where I left off because I got sick and I missed 2 weeks. I had a bookmark in here. If anybody has the free time right now to go back and find where I last read, I was actually only on the introduction. I was reading the introduction. I haven't even gotten to the random numbers yet. If anybody can find where I last let off, I will do a little reading from this book later today. 1,000,000 random digits with 100,000 normal deviates. Okay. So let's get started. Let's actually let's get started talking about WebGL. And what I'm going to do is open up my terminal, and go to the desktop. And I'm going to make myself a little project called p5.WebGL. Then I'm going to open up Atom. And it opened on the desktop. This song is so catchy. Okay. And then let's run a little server. Let's get rid of the sound library, which I don't need. Okay, it's working. Okay, now what am I doing? I've got this open. Oh, not in the right chat room here. And let's see. What else do I need to do? One thing that I should check here. Ooh, let me get a. Oh, this is not good. So, pause for a second. Okay, so as you know, I've been recently using this little node module called P5 Manager. As you know, I don't know if you know this, but I've talked about it. I made a little video about it, and that allows me to generate folders with like the HTML and the JavaScript files I need to quickly put together a P5 sketch. I did just notice here that it's auto-generating a P5 project with kind of an old version of p5.js, and this is most definitely going to be a problem for me right now because I want to use WebGL, and there was a ton of work on WebGL that happened over the summer, which I'm going to talk about. So what I really need to do, first of all, we should P5 Manager, GitHub. Maybe this is something we can help with. Oh, because probably the way that it works is it pulls somewhere it pulls the libraries, which are here. So these haven't been updated for 8 months. So one is that we could do a pull request on P5 Manager to give it the newer version of the libraries. But I think also there's probably somebody can help me with this in the chat. There's probably a place where I could just replace these files in my secret node directory somewhere on my computer. So let's try to do that. So where would node be? Is it in like user node? Where? Oh, no. User var, something like that, right? Is node going to be somewhere in here? Where does the node module live in my computer? Is it in like bin maybe? Is node somewhere in there? I'm going to try to get to n. Node. So I'm waiting for somebody to know this, but I'm going to look it up. So where do global node modules get installed? npm list-g. So that's where I can find them. User local lib node is probably. So let's look at that. npm list-g. User local lib is probably where they are. So I have so many. I don't feel like looking at this. Let's go to user local lib and node modules. So let's open this up. I don't know if this is a good idea for me to do this, but I can go into here. This is where it is. I can go under source. No, not source. Generator, libraries. So this probably is where I can now put the versions of the libraries I want to use. So I'm now going to go back to the browser. I'm going to go to p5js.org. I'm going to go to download. I'm going to download the complete thing. So now I am going to, oh, I just closed that directory. Let me open it again. I'm going to go into generator, into libraries. So what I'm going to do now, wherever I just downloaded those, I want to take this library and put it here. Ooh, I got to authenticate somehow. Replace. Who am I? 24601. Add-ons, DOM and sound. Replace, replace. Can you guys hear the party that's going on out in the hallway? Okay. So now I think I am going to delete this project that I just made, p5 WebGL. I am going to generate a new one. It's there. And now I'm going to go back. And there we go. Look at this. October 11th, 2017. So this worked. So this is something you can do if you followed my workflow. I do think that it makes sense to probably contribute to the node module itself so that it can be automatically updated, or people are installing a new, get a more recent version of P5. But certainly if you are, you can go and kind of, if you have a global node module installed on your computer somewhere, you can go and change that. Okay, I really need to stretch. All right, so we've done that. Now, whoops. So let me open, did this again, same thing. Let me open this up. And by the way, you might be wondering, what am I doing here? Somewhere at some time, I installed a command line utility that allows me to type Atom in terminal, and then the dot means the current folder that I'm in. So if I'm ever in terminal and I want to open up the files from the folder that I'm in, I can type Atom dot. That's not going to just work on your computer. At some point I could do a little tutorial about how to set that up. I don't even remember how I did it. I probably Googled Atom command line utility somewhere. Oh, Alka says there's a command to update. Well look, this was useful. So look, so I'm looking at Gomako also in the chat points it out. So let's go look at this. Let's go to P5 Manager. P5 Manager, update. Update libraries. Oh, P5 update. Oh, look at that. I shouldn't play. That's the sad trombone from me going through all this stuff. And it's actually already a feature of P5 Manager. So I can just do this, P5 update. Yay! Okay, good work, creator of P5 Manager. All right, so that's taken care of. Now, let's run a server. And we are about to start with the first coding tutorial of today, where I look at P5 WebGL. So these are, I'm going to close this right now, close this right now, I'm going to close this right now. Okay, so some, oh, it only updates collections. Okay, well, who knows? I don't know what to do anymore. You've seen the range of possibilities. It's important to keep your P5 libraries up to date. In some cases not. There might actually be something that you kind of released and something changed that broke what you did. And so, but you have the ability to use any version of the library from any point in history. Let us begin. So, do I have a pen that works? Do I have the ability to switch to my whiteboard? I do. All right. How are we doing time-wise? It is 11:20. Feeling a little, usually I feel like doing these streams in the morning is actually better for me. I have a bit more energy. That's not happening to me this morning. Okay. Semver. Semver.io. What is that? Is a plain text and JSON that attracts all available. Whoa. Whoa. Okay. Another day I will investigate that. So what I'm looking for now is WebGL. Here we go. All right, so I don't know. This may end up being a few different tutorials. I almost want to make a list, but I'll make a list during this. All right. All right. Here we go. Oh, where's my bell? Hello. This might actually end up being a new playlist. I'm not entirely sure, but this is the first video in what hopefully at some point will be many videos about WebGL in p5.js. So first of all, this first video, I just want to talk about what WebGL is, how that relates to p5.js, how that relates to maybe other JavaScript libraries like you might have heard of like 3.js, and kind of like how do you just get your basic sketch set up to use WebGL. Okay, so first of all, where do I go for this? I guess I'm just talking. Let me go to the whiteboard. That's going to help me organize my thoughts. There is something called WebGL. WebGL, web, obviously like the World Wide Web. GL stands for graphics library. Now this term comes from another term you might have heard called OpenGL. And OpenGL is an open graphics library. This is a standard. This is a library for doing computer graphics that exists across many different languages and environments and contexts. One of the key things about OpenGL is the fact that it is hardware accelerated, meaning it uses the graphics card, the GPU. The CPU is the central processing unit. I think so. The GPU is the graphics processing unit. Now, someday I'm going to come back and talk about the GPU in a totally different context related to like machine learning. That's not what I'm talking about right now. The GPU is your graphics card that's been heavily engineered and optimized to deal with grids of numbers, matrices of numbers, pixels, images. Any image is simply just a grid of pixels. And OpenGL graphics library is a standard to work with rendering images to your computer screen via the graphics card. So you might have used P3D mode in processing. That is using OpenGL. That's actually a Java environment, so it uses Joggle, which is like Java OpenGL. You might have worked with Open Frameworks, which is a C++ creative coding library, which you can write OpenGL calls directly in Open Frameworks in C++, et cetera, et cetera. I'm not going to go down the road of all the different 3D environments and how they make use of OpenGL or not. WebGL is a standard for doing OpenGL in the browser. And you can write raw WebGL code. You can learn WebGL, and you can make 3D hardware accelerated graphics things happen in the browser. It's very exciting. I am not going to teach you WebGL in the lower level WebGL on its own. What a lot of people do if they want to do 3D in the browser, well, you can do WebGL directly, or you could use a library that kind of sits on top of WebGL and wraps things in a friendlier way with a lot of features to like make all the WebGL stuff happen for you. Probably the most well-known library for doing that is 3.js. Maybe I could pull up the 3.js website and show you some demos. 3.js is amazing. It's been around for a long time. It's had many versions, has tons of features. It is really robust. So if what you watching this video really care about is like, I want to make the most 3D stuff ever in the browser, you probably want to investigate this library. P5, as you know, maybe you know, maybe you don't, P5 is a beginner-friendly creative coding library for JavaScript. mostly focused around 2D drawing, but it also has a lot of other features. Like there's a DOM library for manipulating HTML elements on the page. You can get the webcam. There's a sound library for generating music or listening to the microphone. One of the other somewhat newish capabilities of p5.js is a WebGL renderer. And kind of coming back from the history of processing, one of the ideas, the central ideas of processing in the beginning was what you could sort of flip a switch. You could write all this code, it renders in 2D, you flip a switch to 3D, and that same code works in 3D, and you can start to add more stuff. Whereas working with something like 3.js is really a whole different way of thinking about things, because 3D in the end kind of works in quite a different way. So p5.js, in the same way as processing, the sort of goal here is, can you write a p5.js sketch and sort of just convert it into 3D and add some new functionality? And that's what I want to look at in this set of videos. So how do you enable WebGL in p5? It's actually very simple. Create canvas is the function where you specify a width and a height for a graphics context that you intend to draw in. And by default, that graphics context is a 2D HTML5 canvas. If you give this create canvas function a third argument, WebGL, suddenly this context becomes a 3D context. And there are new functions that you can call. I should make a list of these things. Things that I want to go over are 3D geometry, camera stuff. What's the camera? Ooh. Texture. Oh my goodness, textures. What else? Material. Lights. There are all these new, in some ways you're relinquishing a lot of that control. When you draw in 2D, you really say like this pixel, this exact pixel, set that exact pixel, this color. Working in 3D often becomes more an exercise of setting up a scene and placing the camera and adding some lights. You're kind of relinquishing some of that pixel by pixel control by getting an engine that can create this illusion of 3D perspective for you. So this is what I want to, in this video series, I want to look at all of these pieces. This is the overall picture. So let me go back to the computer. And I'm going to see, I've got a chat going, I'm going to see if there are any questions come up. But first I want to give credit to where credit's due. So lots of people have contributed to p5.js. So the creator of p5.js is Lauren McCarthy, and many other people have contributed to p5.js. The WebGL library was started by Kevin Seewoff, I believe. Karen Pang did a lot of contributions to it as well. And most recently this summer, two students, whoops, I went the wrong way, Kate Hollenbeck and Stalgia Grigg, both worked on overhauling the 3D rendering mode WebGL. My shoe is untied, so while you're reading that text right there about the amazing work that Kate and Stalgia did, I'm tying my shoe. So did a ton of work. And so I'm just going to quickly click on these links, read more from Kate here, Stalgia here. This is some documentation about all the work that they did over the summer and the different features, what's still missing from WebGL. It is pretty new. I'm sure there are bugs, but I want to make sure I sort of credit this work. And then the other thing I would mention here is this tutorial, Getting Started with WebGL and P5, which is a wiki page, is pretty much what I'm going to go through during this tutorial. I mean, you may find some bugs. I did a video on WebGL like probably a year ago, which was just kind of like looking at what works, what doesn't work. So, but the work that Kate and Stalgia did over the summer was tremendous in getting so many features back up and running and working. So I'm excited to be able to look at that with you. Okay, so let's do something really exciting. Oh no, the camera went off. Let's do something really exciting just before this video ends. I'm going to go to my code and I'm going to say create canvas 400, 300. And I'm going to say background 51. And I'm going to say rectangle 0, 0, 50, 50. And then I'm going to say fill 255, 0, 150. And now I'm going to go look at this sketch in the browser. Ooh, oh, first, I want to do, let me remove the reference to the sound library so I'm not using it. Okay, there's the sketch. Okay. All right, now, everybody, stay with me, stay with me. I am going to add to my code, I'm going to make this sketch 3D, okay? Now, take a deep breath. It's all going to be 3D now. It's going to blow your mind. I'm making this 3D now. Here we go. I'm going to hit refresh. Woo! Ha! Look at that, it's 3D. So one thing that's really important to mention, I'm being ridiculous here, is that, what am I even trying to say here? Time out, let me do that again. I tripped over my microphone. I don't know if you could heard that, messed up the sound. All right. It's a little... So what I'm trying to point out to you here is that the rendering context has changed, and suddenly the functionality of P5 has changed as well. Why do I not see the fill color here? Well, if I haven't thought about some questions around things like materials and lights, maybe I can't actually see that color without light being present to sort of illuminate the color. Why is this at 0, 0 suddenly in the center? Well, P5 WebGL mode considers the origin point in the center of the canvas, not in the top left. So as I go through this tutorial and we look at all these basic pieces, and I go through, whoops, and I go through geometry, camera, texture, material, lights, we're going to see how things work in 2D versus 3D, what works to mix between those two modes, what kind of remains exclusive to 2D or 3D. Okay, wonderful. See you in the next video. Maybe. It's okay. Maybe, we'll see. Okay, goodbye. All right. All right, so I'm, oh, thank you. So I've got a time code to the last live stream where I start reading random numbers. Thank you for that. I will come back to that later. Simon put together a gist. So let me open this up. Gist.github.com Simon Tiger. And then I'm going to take any WebGL questions. Or if I got anything, did I get anything wrong? Did that explanation make sense? I didn't open up the 3JS website. I meant to do that. So let's look at this. So this is, thank you for this, Simon. This is awesome. So this is all the different primitive shapes. Thank you. That's terrific. Okay. Let me look at the, if any, let's see, where are we on time-wise? 11:30. Okay, so I want to move on. The first thing that I think that I will look at is just 3D geometry. I think so. We'll see. Okay. Let me get some water here. You know, I actually have had some recent inquiries from sponsors. Oh, I'm in the wrong camera. But as you know, currently, the Coding Train is brought to you by H2O. It's liquid, you drink it, and you live. All right. All right. Okay. I'm not seeing any questions. I'm not seeing anybody saying anything like I completely botched this explanation of, oh, I didn't mention shaders. That is kind of an aspect of this, but I guess I can come back to that. All right. It's very loud in the hallway right now. All right. So here we go. It's 11:30. I got to keep moving here. So I think the first thing that I'm going to do is look at primitive geometry. Let's just look really quickly. So I can close this I talked about. I can close this. I can close this. I want to keep this open. This is useful as well. Let's also go to the reference page. We're going to need, let's see here. Models is something, 2D, 3D primitives here, okay. And there's one other thing. Oh, let me just look at the examples. Learn examples 3D. Let's just look at this. So this, all right. So I basically want to go over this very briefly in the first video. I'll make something like this. Okay, great. Okay. All right. Here we go. All right. All right, I'm back. So this now, in this video, I'm going to look at three-dimensional geometry. Now, first of all, actually, let's not even look at three-dimensional geometry just yet. This is three-dimensional geometry. It's a rectangle. Let me do a couple things. I'm going to just get rid of the fill. So it's fine that it's black right now. We'll deal with sort of color and that sort of stuff later. I'm going to just change the background to 255 so I can see it a bit more easily. Or I like to see where the canvas is, so I'm going to make the background 175. Okay, now I'm going to also say rect mode center. And let me make it like a little bit bigger. And let me actually make it a rectangle so we can see. Oh, look at that. Whoa. Oh, cool. So look at this. This is such an exciting moment here. Why? What's that? So one thing you will soon discover if you choose to embark on this journey into 3 dimensions is that shapes, if you think of like, oh, we're going to make a sphere or a torus, which is like this donut shape, or a pyramid, shapes are actually, three-dimensional shapes, three-dimensional geometry are really collections of lots of small 2D polygons all tiled next to each other. And we're going to see more and more examples of this. And amusingly, through whatever sort of default rendering that's happening right now, I'm seeing the full, what's often referred to as the wireframe of this rectangle, which I don't know why suddenly that appeared, like when it wasn't before. As soon as, like, but, so let's see if we can, let's see if I can say no stroke to get rid of that. There we go. And now it's white. I'm just curious, let's give it a color. Now it's black. Ah, interesting. I don't know what I did before. Let's give it, yeah, okay. So I'm in WebGL, and this is the thing. I can still work with two-dimensional drawing in the same way. But how can I prove that I really am in 3D? So one thing you might have noticed that that you could do, let's make a variable called angle and set it equal to 0. And I am going to, right before I draw the rectangle, say rotate by that angle. And then I'm going to, every time through draw, increase the angle a little bit. Angle plus equals 0.07 or something, some arbitrary number. So let's refresh. Now look at this. What's this? Cannot read property transpose 3 times 3. This looks horribly and scary and awful. Let's see if we can find somewhere. Okay, so it would really be nice. Someday we're going to figure out a way for P5 to give us a little bit of a friendlier error message. And actually, if you go back to that processing.org Medium blog, you'll see that Alice Chung has worked on this whole P5.js friendly error system. But that's a separate, the reason this is happening is that rotate in 2D, if I have a two-dimensional plane, this is a two-dimensional plane, and I say rotate, there's only one way to rotate. But if I'm living in a three-dimensional world, I can now rotate by what axis? This is the x-axis. So this is rotating along the x-axis. This is the y-axis. So this is rotating along the y-axis. Or the z-axis is the equivalent of rotating in 2D. So I could say rotate z and refresh the sketch. Let me move this over a little bit. Suddenly, there we go. I've got my rotating square. Now, are we really in 3D? I'm not sure yet, but let's change this to rotate x. Now we can see the three-dimensional. Look at this. That's like, I'm very worried it's going to hit me in the face. Now, the important thing to realize I mean, this might seem so ridiculously obvious, but I feel obligated. I must state it. This is still a two-dimensional plane. There's nothing three-dimensional about this. All we have done is unlocked a separate rendering engine which knows how to create the illusion of 3D perspective. So who's to say whether I have a square and make it bigger and smaller, is the square growing and shrinking, or is it zooming in and out in the third dimension? But this is definitely an effect you could, as a coding challenge, I might say, recreate this without WebGL, and you probably could figure out, like, could you like maybe oscillate the vertices of this quad up and down to create this shape that looks like it's spinning. But this is why WebGL exists, so that we can just kind of do stuff without it. So I can also now say like rotate Y, and I can say, just can like have it rotate maybe like slower along the Y-axis. And we can see now, here we go, I've got this spinning plane. Now all we got to do is put General Zod in it, and we have the end of Superman 3. Is that right? Flying off into space. And I can add rotate Z, angle times 1.2, and we can see now I have all three axes spinning. So this is first step number one. Now so that's a 2D plane. There actually is a plane primitive in 3D. So the question is, we can use two-dimensional shapes that can live in a 3D world, but we can also, and just like there are these 2D primitives, arc, ellipse, line, point, quad, rect, triangle, there are now this whole list of other 3D primitives. Plane, which is essentially what I've just done, box, sphere, cylinder, cone, ellipsoid, torus. Let's look at box. So I'm going to comment out this rectangle, and I'm just going to say box. Now, what if I don't put anything in there? Probably I'm not going to see anything, I would think. Oh, look, it gave me some default. You can kind of see that there's something 3D there, right? It's a little hard to totally see because there's no shading, there's no lighting. So the three-dimensional illusion becomes much more prominent once we've added more stuff. But one thing you can see here that I can do is with box, if I say 200, now I have a box what are the dimensions of a box? A rectangle has width and height. A box has width, height, and depth. So I can actually start to play with all of those. 10, 100, 50. And you can see now I have this spinning rectangular box that has a separate width, height, and depth. So this is the basics of working in 3D, which is that you can just create shapes. Now here's create three-dimensional primitives. You can color them, and you can rotate them. Here's the thing though, how would I move this throughout the three-dimensional space? Well, rectangle, right? Rectangle, I give it an X, a Y, and a width and a height. Box, I gave it a width, a height, and a depth. I think it's that order. Could I also give it like an X and a Y, like -50, 10? No. Cannot draw a stroke. Something's going on like crazy. So that's just plain wrong. The only way to position these three-dimensional primitives in three-dimensional space is with the translate function. So in 2D, you can use the translate function to move the origin point around and draw stuff relative to it. Same thing in 3D, but the translate function is really required. So if I did something like translate mouse X, mouse Y, oops, and you can see I'm kind of like, whoa, somehow it's sort of moving. Now here, once again, this is the thing. I've really relinquished pinpoint accuracy of pixels. First of all, did I translate before I rotated? Did I rotate before I translated? What I really wanted to do was translate before I rotated, at least for the effect. That makes a big difference here. Because what I want to do is show you like I can, but remember, 0, 0 is the center. So if I really want to move it with the mouse, I'd probably need to say translate mouse X negative, oh my God, negative, width. Oh wait, hold on a second. If I'm oh, this is hard. If 0, 0 is the center and mouse X is at the center, what do I want to do? I just need to subtract that center out. So I need to say minus width divided by 2 minus height divided by 2. And I now have this 3D shape that I'm kind of moving around with the mouse. But again, 3D, right? I'm only translating along the x and the y axis. Something else I could do is I could say 0, 0, don't translate x and y, but translate by the mouse along this, use mouse x to translate along the z axis. So now you can see as I move the mouse left and right, the spinning rectangle is zooming in and out. Okay, yay! I'm taking way too long to go through all this stuff. Let's look at some of the other shapes. And by the way, Coding Train viewer Simon Tiger created a nice little GitHub gist that has a quick reference for all of these. So let me look at one of these. Like I really like the torus. Torus is essentially a donut and looks like a radius and a tube radius. Let's try that. So torus, and let me give it a radius of 100 and a tube radius of 10. And go back to my sketch. And we can see, and let me not zoom it anymore, just rotate it. And you can see there's my nice little three-dimensional ring. So the tube radius is there's almost like the thickness of the donut, right? So if I were to make this 50, you can see that this is a much more delicious donut to eat because it's fatter around and the actual radius itself is the radius of that circle. So I could make that 50 with 10. You can see now I have a smaller one. So I could keep going through all of these. There's cone. I don't know. Let's go back to that list. There's plane, box, sphere, cylinder, cone, ellipsoid, torus. I encourage you to explore those on your own. Take a break. See if you can. There's actually a nice example on the p5.js website, which I will go right now. Learn examples. Under WebGL 3D, I'm going to go to geometries. So here we can very quickly see, here are all of them. Let's see if we can figure this out. Plane, box, cylinder, sphere, torus, cone. So what I would say is, like, as an exercise, see if you can recreate this, position all of these shapes, rotate them, see if you can get all of these primitives to work. You will notice here, why are they have this nice like rainbow color, and that has to do with material. So I think perhaps in the next video I want to quickly look at material and texture to see how those work in 3D as well. Okay, thanks for watching. All right. Oh boy. Quaternions. What if the tube radius is bigger than the radius? Interesting. Okay, how are we doing here? We need to drink a little water. Normals. Oh, you guys and all your 3D stuff. Okay. Yeah, I should mention your browser has to support WebGL. If the browser doesn't support WebGL, none of this will work. All right, let's see, what am I going to get to next? So let's do material and texture. So let me go to this tutorial. I probably should use the lights first, but let's do this. Oh, interesting. Normal vectors, it automatically maps the geometry's normal vectors to RGB colors. Okay, I'm reading this. Huh. So it does, however, the total color is affected by the light. Oh, normal material. Ah, okay. Specular. Okay. All right, so let's try talking about materials. It's the kind of like materials and light. I don't think it makes sense to talk about material without light. So let's do materials and lights in one video. And I can try to use these. And let's see, Simon's helpful just here. Weight will probably show up with those things at some point. Okay. It's a material subject, yes. All right. Okay. Here we go. Where's my marker? Where's the good? Ah, here it is. I think. There's just markers everywhere in this room. Is this the one that I was using? That's good enough. All right. Okay. Hello. So in this video, I think I want to look at both lights and material. First of all, I really barely know this 3D stuff, so thank you for correcting all the things I'm saying and giving me extra help in the comments. I'm sure that's going to happen. But it doesn't seem to me like it makes too much sense to look at the different materials and what is a material without having different lights, because material, the kind of material you apply to a piece of geometry affects the way it looks based on the lighting. Anyway, so just going back to this list, all I've really talked about so far is 3D geometry. And you can, by the way, create custom shapes in 3D as well by putting together multiple shapes or by using begin shape, end shape, and vertex. Maybe at some point I'll come back and look at that. But I'm really just focusing on the primitives right now, the primitive shapes. So what I want to look at, this is I guess out of order, is I want to look at material and lights. So let's look at that in this video. So coming back over here, so we have our torus. My favorite 3D shape is a torus. What's your favorite 3D shape? Primitive. And I'm going to go to the Getting Started with WebGL tutorial, and I'm going to look first just under material. So these are the 4 kinds of material. Normal material, basic material, ambient material, specular material. Actually, this is the first time working with WebGL and p5 that I've ever really encountered this terminology. And material really describes how the light reflects off of an object. Let's actually just change right now. I'm gonna get rid of this fill. You're probably not really supposed to use fill with the 3-dimensional shapes. You should really use material and lights. But I'm gonna comment out this fill. And let's make this torus a little bit bigger. Let's see how it looks. Whoops. There we go. Ooh, okay, so now this is just the torus with no fill, no lights, no material. Now let's add a normal material. Normal, the way I do that is by saying normal material. And look, so one thing the normal material does, and there's this, oh boy, I think I might have to talk about normals. Oh, and detail. Okay, so first of all, let's come back to something. Do you remember there was a time once in a previous video where I had stroke in there? I'm going to put that back. Stroke 0. I should probably use a sphere, but let's stick with the torus. Look at this, and let's slow down this rotation by quite a bit. So look at this. This is now what a 3-dimensional shape is actually a tiled set of polygons. And what you can see here, these are actually referred to as triangle strips, because you can see how there's strips of triangles. They're all flat shapes. These are all flat 2-dimensional shapes, but when layered next to each other and bent ever so slightly, you can create the appearance of a 3-dimensional shape. Now, one thing that's really important is the level of detail here. So one thing I want to just quickly examine, we'll go to the reference. Let's look under torus and see if there is a detail. Detail X, detail Y. These are, I know I said I was talking about lights and material, but I think this is important. Detail X and detail Y refer to the level of detail. How many polygons do we use to create that? The default is 24, and the default is 16. So in other words, if I add 24 and 16 here, we should see exactly the same shape. But let me now go and add 128. Whoa, okay, cannot draw strokes on a torus object with more than 24 detail. So it's actually like saying to me, you know what, I appreciate that I'm having all this detail, but I can't draw the strokes now. So that's interesting. I wonder if Sphere would perform the same way. But let's do the opposite. Let's make the detail much less. So you can see, and let's change this detail from 16 to 4. You can see that this still has that torus-like shape, but it is much more jagged. It doesn't feel rounded anymore, because the more detail, the more polygons, the more the illusion of it being rounded it feels like. It's kind of like drawing line segments to make a curve. The more points you have along those line segments, the more curvy that might look. So that's an important thing for you to realize. The reason why I bring that up is material. So all three-dimensional shapes, I'm just going to draw over here. So let's say you have one of those triangles, and I know I'm just drawing an arbitrary 2D shape on here. There is a term that you'll see when you're reading documentation called normal. And the normal refers to the perpendicular line segment from the plane of that polygon. In other words, this. So this is the normal, and I could kind of try to draw it, with the illusion of 3D by drawing like an arrow like that. So the normal is, if my head was a 3D model and there's a little triangular polygon right here, this might be the normal. And that normal is what kind of controls how the light reflects on it and how it appears when you see it in a computer graphics context. Let me pause for a second because this says, I want to see if this is actually going to be helpful. Oh yeah, so this is helpful. So let me come back. Where was I? Something like this. So there's a nice Wikipedia page that I think has a diagram called normal geometry, and you can find out more about this. Surface normal, here's a polygon, there's two normal vectors, one points that way, one points another way, but I'm not going to get lost into this, but the reason why I bring this up is right here you'll see normal material maps a geometry's normal vectors to RGB colors. So what does that mean exactly? Why is it like rainbow? Is it because I didn't put a texture on it or no lights? Like, if I, why does it show up with that rainbow color? It's because I haven't textured it, or I haven't, is it affected by the lights? Well, I need to time out for a second here. Let me just see an ambient, ambient material, ambient light. Look, let me add an ambient light. We don't need this anymore. Oh, X, Y, Z control RGB. Oh, that's what normal mapping does. Okay. So when do I want to use, when do I want to use the normal mapping? Just when I want to see just for debugging basically? Oh, wait. Yeah, just for debugging, I guess. Testing. Thank you. I got it. This is, by the way, do you realize that I make these video tutorials, I really don't know what I'm talking about, and then the chat gives me the answers, and then I pretend I know what I'm talking about. I guess I knew stuff at one point in my life, but time moves fast. I'm an old person programmer here. Okay. And I'm like a 2D numbers programmer person. Okay, I got it, thank you. All right. So, got it. I'll come back to this. So, where was I? I was here. Oh, so loud in the hallway, I gotta take a break. This is just for debugging, normal map to the actual lighting calculations in the shader. Can we please get more polygons? Okay. All right. We got to keep this moving here. This is an exercise in making a tutorial about WebGL, learning WebGL, and making a tutorial at the same time. Okay. Right. So you don't got it. Okay. Thank you, everybody. I got this. So why would you use normal? The truth of the matter is, if I come back here and look at the. Okay, wait. I was saying, now I lost what I was saying. Okay, I got to go back here. So basically, it's taking the X, Y, Z locations, thank you to the chat for helping me with this, to create RGB colors. And that's why the X is red, the Y is green, the Z is blue. And that's why once I add back in this normal material onto the torus, we see this rainbow color. The truth of the matter is this is really just for debugging. So if I haven't figured out like what the lighting is and the fill is and the texture is, all this other stuff, I'm really going to be able to easily see that this is like a 3D shape because of the sort of rainbow color scheme. And I know this is, well, I got to add, let me add the polygons back in and we can see this here. Okay, so that's what a normal is. That's what a normal material is. There's our torus. Let's move on. So let's look at some of these other materials. So basic material is a material that fills the geometry with a color. So it's really what you should use instead of fill. So if I change this to basic material and I give it green as a color, basic material is not defined. What did I do wrong? Basic material. Hold on a sec. Basic. Oh, does basic material not exist anymore? So interestingly enough, whoa, let's try to time out. Why was basic material, why is basic material removed? Because let's see if we can find a GitHub issue about this. Shoot, I'm not going to get nearly as far as I had hoped. Issues. Which no longer exist. Fill or normal material. So fill is actually, basic material. So this happened over the summer. We can see the work by Kate Hollenbach here. Let me see if their default stroke and fill basic material missing. Let's look at this. As fill does the same job. Okay. So, boy, that tutorial is out of date. So let's edit this tutorial. Let's correct this tutorial and I will go back. Where basic, so I'm going to get rid of this. I'm going to just like at one time there was also a basic material which fills the geometry with a color but is not affected by the light function, which fills the geometry with a color but is not affected by any of the light functions. However, due to it being the same as fill, it was removed and the function fill can be used in WebGL to map to fill geometry with a color. Okay, so let me get rid of this. While I'm here, it drives me crazy that these are not syntax highlighted functions. So if you can bear with me here. All right. So let me save this. Okay. A material. Okay. And okay, I probably should link to something there, but that's fine. Okay. So you wrote the instead of in. What did I get wrong? At one time, there was also a basic material which fills the following geometry with it. which fills with a color but is not affected by any of the light functions. However, due to it being the same as fill, it was removed, and the function fill can be used with WebGL for the same functionality. That's probably what I should say. Let me edit this one more time. Can be used with WebGL for that functionality, for the basic material functionality. Okay. All right. Okay. So let me come down here. Oh, you know, I'm like, someday I'm going to have to do like I don't know if anyone's seen the old Phil Hartman Saturday Night Live sketch, Anal Retentive Chef, but I unfortunately am the anal retentive coder, and I cannot bear, don't be like me. Don't be like me. Save yourself. I cannot bear to look at this because there are no spaces before that 0, but there are spaces up here. I have to correct that. I'm so sorry. It's driving me crazy that that there's not a line break there. Just everybody here. Hold, please. Is there anything else I really need to correct while I'm here? Okay. All right. That's better. Okay. All right, let's move on now to basic material. Wait, no, try it again. Let's move on to basic material. Now you might have noticed while you were watching the beginning of this video, it said basic material there, and then all of a sudden, the tutorial changed. I took a little break and I edited the tutorial because basic material, I was wrong, something I said earlier was wrong, has actually been removed from the p5.js WebGL rendering mode, because what basic material does is fill the geometry with a single color. And in fact, what also does that? The function fill. So I updated the tutorial to reflect this, and we can now go in and say, so I was trying to debug this here, and I got an error, which I think is probably still in the video, I'm not sure. So I can change this to fill 02550, 0, and I can then go back to see my torus, and we can see, there it is. There I now see the green torus. I could take out the stroke. I don't need this rect mode anymore. And these things, and I could, so now we can see, now look at this. Here's the thing. Now one thing I should show you, let's change this from a torus to a sphere. Do you see a sphere? Look at the beautiful round three-dimensional sphere. It looks so much like a flat ellipse. This is because without any lighting, a sphere, or without any change in perspective or change in lighting, it just appears completely flat to me. So one thing we should try to add to this is some lighting to see if we can see the shading of the sphere. So let's kind of look back at lighting. And one of the quickest way to add lighting to a scene is something called ambient light. So I can go back and just right here at the beginning, I can just say ambient light. And let's say the sphere is blue, and I'm now going to add the ambient light of red. Let me comment this out first. So there's my blue sphere. Now I'm going to put the ambient light of red in. It looks no different. So here's the thing. Fill, which uses a basic material, does not actually respond to the lighting in the space. So in order for the material to respond, we need to use a different material. And so if I come back to that tutorial, we'll see here that ambient material is like, I need to correct this. Pause. Freeze frame. Let's see if I can edit it. And look for, basic material. and hit save page. Back magic. I'm sure the zoom it doesn't match, but ambient material is like fill. However, the total color is affected by the lights. So let's go back now and change this to ambient material. So the ambient material is blue, the ambient light is red, and let's see now what we get. All right, interestingly enough, why did that fail? Oh, the smudge at the bottom. Oh, look at this, came off. Sorry. Thank you. How long was that there for? Yeah, so, okay, hold on. It's not a green cloth, it's actually just green construction paper. So let's go back and add the ambient material. All right, so what is going on? Have I encountered a bug or have I done something wrong? Ambient material is like fill with the total color is affected by the light functions. Whoops. All right. So if I don't have any ambient material, I see the light reflecting off of it. If my ambient material is white, let's look at the ambient material reference. Oh. No. Gray, red, or hue value, green. So I think something is broken. I think something is broken. Let's try to test some stuff. Let's get rid of the ambient light. Okay, that didn't work. Oh, without any light though, then it won't pick up anything. Okay. Yeah, that's working. No, I know. Yeah, you're right. So the ambient material won't actually see the shading. I just wanted to see the combination of the color. So, but I'm confused why. Let me give it white light. Whoa. Oh, it needs an argument. So white and white should be white. White and gray should be gray. Okay. White and kind of like dark. Oh, that's working. Oh, I know what's happening. I mean, I thought it would mix the colors, but I think it's not able to illuminate. This is 0. So this is basically just illuminating that aspect of the color. Because it absorbs all the, yeah. So, so maybe this was a bad direction to go in, because now if I do this, right, it's there. So, and I'm not going to get any shadows because it's ambient light. So, okay. Let me back up here. No color is reflecting. Okay. So, I think I know what I need to do now. Sorry. This is so often what I do is I do these like tutorials in a workshop here at NYU. I figure all this stuff out. Then I come and do it as a video, but all right. So, so where was I? All right, so I'm going to have to explain this. What was I trying to do? Let me just go back. From the docs. Point light, yeah. Ambient light, point light, thank you. It's multiplicative, yes. That is such a good point. Okay, all right, sorry, let me go back. So I'm going to go back to where I had fill. So I'm going to change fill now to ambient light. And look what's going to happen. Whoops. No, not ambient light, sorry, ambient material. I'm going to change fill to ambient material. And look what's going to happen. Nothing. I see nothing. Well, here's the thing. Ambient material needs light to be able to reflect back that color. And in this case, it's I guess multiplicative is a way of thinking about it, but you can see there's no blue light, so I can't see any of the blue color. If I gave it a little bit of red here in the ambient material, we're going to see just that red. It's reflecting now. Or if I made the ambient light all white, I'm going to see that actual color. But here's the thing. I said I wanted to be able to see how this was 3D. And I kind of misled myself or misled you in that ambient light is this kind of magical light that exists in equal amounts from all directions. So in that case, we won't actually see any shadowing. What I want to probably use to see some shadowing is a point light. So let's do that. A point light, if I go to the reference, is a light that has a color and a position. So I can give it an RGB value and an XYZ value. And yeah, there's a bunch of different ways I could give it a full color, but let's use all the values just for simplicity. So let's give this point light 255, 255, 255, and let's put the point light at, let's put it off to the left. So I'm going to say like -200, 0, 0. So what that's going to do now is it should be, you can see the point light is somewhere over here, and you can see this shading now. It's as if it's not a flashlight, that's a directional light, but it's a point light. So it's a light that emanates in all directions, but from a single source. So for example, if I were to now make this light red, and then make another point light that's like blue, but on the other side, we can see, and let me give it the material. What did I do wrong here? Let's put this one second. Oh, weird. So this seems a little bit like buggy in that, why can't I have one? This one seems to be, let's make the material all white. Maybe I'm not going to go down this road. Is this a bug? Have I found a bug? Right? Shouldn't I be able to have 2 point lights, one from one side? Not just the second one apply. So this seems like a bug to me. What if I put it like, no, it doesn't change anything. Yeah. So I think the bug is happening. I have a feeling that some of the examples are using different. I'm gonna just back up. I'm sorry, making a big editing mess for you, but I'm not gonna add the second light because it doesn't work. And I'll have to investigate that at a different time. So we could also, this is what I had originally, right? Point light. Wait, hold on. What did I have? And then I just made I think I did this, right? Did I do that? I don't even remember. Where was I? Yeah, it redefines the current point light as opposed to adding another point light, which to me is a bug. You should be able to have multiple point lights. Let's see what happens if we put the point light inside the sphere. Whoa, so you can see it's kind of like coming from inside. So the other thing I could do is I could try to give it like the mouse location. Remember, I need to offset by the center if I'm using the mouse. And you can see now, as I move the mouse around, I kind of have that point light moving. Let's switch it back to the torus. And we can see here, same effect. So now we can start to see that shading from a point light. And older version totally works. All right, so we got to file that as a bug. Yeah, I wonder if I should just revert the version and show this in the tutorial, and then we can fix this bug another time. Ironically, I was making sure to update my version. I'm going to just leave it. We'll come back to it and fix that bug. Okay. So let's see. All right, let's keep going. Okay, so what else am I missing here? So far, I haven't shown you a couple other things. One is there's something called specular material. And specular material is a shinier material. It reflects the light in a shinier way. So if you wanted to kind of like that sort of billiard ball-like quality or more like water or metal quality, let's just even see how this looks here. You can kind of see, yeah, as I move it, it's a little shinier. Now, everything is so dark, so let's make the specular material white and the point light kind of this like pinkish color, and we can see here, yeah. So you can see specular material, it's definitely revealing the level of detail in that torus and the geometry. I could also add, by the way, just an ambient light that's just white to kind of illuminate the scene a bit more. Oh boy, that ambient light really took over. I think the lights are broken. Looks like you can only have one light in the current version of P5. Strange. All right, maybe I should revert, because this tutorial, I could secretly use the older version for this part of the tutorial. And then we can make sure to fix P5. Can we make a commitment to that? I think what I want to do is just, how do I get the 0.5.7 I got to go back to? Where is the, just right, oh, here we go. So what I'm going to do is here, I'm just going to really just reference this version of the library. I'm going to go all the way back now. Well, see, there's other weird bugs. Ugh. Sphere. Ambient material. I forgot what I was doing. This is kind of like where I was. Oh, I hate that this error is here. Oh, that's annoying. And then just see that this works. Yeah, it totally works. Ooh, this would be nice to demonstrate. This would be nice to demonstrate. There's only one ambient light in 3D worlds. But shouldn't I, now if I were to add an ambient light and make that light like greenish? Oh yeah, that worked. Sort of. What if I make it white? It takes over. I guess it's so bright. Yeah, you can definitely only have one ambient light. I guess it's just because it's so bright, it washed out all the other colors, so that's not worth showing. Is there any way I could disable this warning? Anybody know really quickly how I can, how I can disable warnings? Show only errors in Chrome Development Console. And that link is helpful, but I would prefer just the actual instructions. There's an option right there at the console, the down arrow at the top. The down arrow at the top. Here we go. Top. No. Default levels. Warnings. Okay, great, thank you. Okay, I don't know if this is a good idea, but what I'm doing in this tutorial now is I am creating a tutorial where I'm quickly switching to an old version of the P5 library to get a piece of functionality working. And then I'm going to complete the tutorial and switch back with the idea that I'm now taking on the responsibility of making sure the P5 library itself gets updated so that when people watch this tutorial and use the code, that it actually works. So, no, that warning is like an old bug from the old version of P5. It's not relevant. I just don't want it to show up. Errors are important. Warnings, I'm like a programmer who's like, it's just a warning. If it works, who cares about the warning? Don't be like me, though. Don't be like me. I've got lots of problems. Okay, so the question now becomes, how could I possibly undo all the way back? I'm going to try. Mathieu, I am so sorry for everything I have ever done. Oh wait, I went too far. Yes, okay. Here's where we were. Okay. All right. All right, now let's try adding a second point light. So what if I add a second point light and put it on the other side? You can see it's illuminating both sides. What if now this point light was kind of like reddish and this point light was kind of bluish? We can see, and let me make the ambient material just white, because this is really what I want to do here. We can see now that those lights are staying in the, now interestingly enough, the lights are not being affected by the translation and rotation. However, if I were to put the lights after the rotate, yeah, no, the point lights don't get affected by that. Never mind, to edit that out too. This is such a disaster. I can't just get these ideas. I'm not going to move the light. Okay. So one thing that I think might be helpful is actually to see these lights move. So another thing that I could do is I could actually just say, let me put the lights at mouse x minus width divided by 2, mouse y minus height divided by 2. So you can see now that this, whoa, I did something weird. Mouse x, mouse y. Oh, I guess the light, that makes sense. The light, oh, is this right? Oh, because it's flipped. The axis is also flipped up. Oh my goodness. So, hold on, back up again. Oh, this is such a mess. How come I didn't notice that before? Just give me a break here. Drink some water. Oh my God, it's 12:30. I'm never getting to this coding challenge. Shoot. You know what would probably be better? For me to actually just completely start this whole tutorial over. But I guess I'm too stubborn to do that. Okay. All right, now let's demonstrate moving some of the point lights around. So one thing I could do, for example, if I, let me get rid of the red one, and the blue one, just keep the red one, and I'm going to put the x location at mouse x, and I've got to offset by the center, minus width divided by 2. So we can see now, as I move the mouse, I can affect that point light. Now the y is not changing. Here's the thing, I just realized something. I am going to put the y at mouse y minus height divided by 2. And look what's about to happen. Uh-oh. So one thing I forgot to mention is, in addition to the difference with 0, 0 being in the center for WebGL rendering, whereas in the top left for 2D canvas, the y-axis actually points up. So what I think that I want to do is say negative mouse y plus height divided by 2, and now I kind of have this point light that I can move around with the mouse. I could obviously move the z location. The point is, the point light of it all is that a point light is a single light source that emanates in all directions that I could give a location. Okay, now let's put this back. Back to being a torus, because it'll allow us to see the rotation stuff a bit more. And you can see this now. I still can move this light around. It's spinning so slowly. Let's spin it a little bit faster again. So we can see here I can move the light around. I have this spinning torus. Now, there are two other things we haven't looked at. One is another type of material called specular material. So specular material is just like ambient material in that it reflects the light, but it's shinier. So if you want to do something like a billiard ball or some like kind of metal-like looking surface, you can use specular material instead. So I'm going to change this to specular material from ambient material. We're just going to look at what it looks like differently. Okay. So you can see it has this kind of shinier quality to it. You know, I might want to do something different with the lights. You know, maybe what might be nice is to actually go back to having these two different point lights that are just on opposite sides, negative 200, 0, 0, and we can kind of see, you can kind of see here a bit more about the sort of like shininess of this material. Anyway, so playing with lighting and playing with material is going to make a big difference in the appearance of these particular objects. I wonder if I add a fill, I think it would just take over, right? So one thing to realize is if I add a fill, like if I just add like a green fill completely takes over, kind of, it's adding a basic material. You can only have one material. You can't have multiple materials. So the second one replaces the first one. However, you can have multiple lights. There is some bugginess between this. Hopefully by the time you watch this video, this point light stuff will work for you. If it doesn't, make a note in the comments and I'll try to reply to you. But there's one other kind of light that we can look at as well, and that is directional light. So this is pretty tricky. Directional light is, wait, hold on. This doesn't seem right to me. The documentation looks wrong. Red, green, blue, position. It needs to have a direction. You know what? I'm going to not include, I'm going to come back and do maybe a video with the directional light, because this is absolutely, right? This cannot be correct. With a directional light, a fill with alpha, that's interesting. I should try that. A directional light, right? A point light is a single light that emanates in all directions. A directional light is a single light that emanates in one direction. So you need the color, you need the position, and you need a vector that defines its direction. I don't see any of that in this documentation here. Right, it would need position and direction. Or does it just get placed by translate? The direction of the light. Oh. So how do you have to position it with the, do you have to position it with translate? There's no position for directional light, it's from infinity? Oh, really? Let's look at the tutorial. Oh, okay. Do not have any specific point of origin. and therefore cannot be positioned closer or farther away. So what's like a flashlight? Where you have a directional light in a position. Does it have a name? Is that called something? Directional light is like the sun. Okay. Do not have a... all right. All right. All right. All right. All right. So let me just... Let's try this real quick. Let's just stick this in the code. So I guess I will do this. So that's directional light, which is quite nice actually. Flashlight is a point light. Okay, let's try the directional light. Okay. So what's a nice way of saying the difference of directional light? Well, okay. Directional light is ever spotlight. But is there a spotlight function in the reference? Yeah. So maybe someday that'll get added. Yeah, okay. All right, everybody. Do small, do small. Okay. I know Spotlight is in processing. I just don't see it in P5. Boy, what a mess this is. I should just, Mathieu, as you watch this eventually, I would be very happy actually just like redo this. It would take me probably like 15 minutes now that I know what I want to like show and how to show it. But we'll see if something gets edited. If something can actually be edited together, great. But I could just, this is a good learning exercise for me. I'm happy to just come back and redo this if it's too much of a mess. All right. So there's one more light that I want to look at called directional light. So directional light is a light that, it's kind of like, you can think of it as like the sun. So it comes from like an infinite place far away, but points in a particular direction. So what we need to define is the color of the light and the direction that it's pointing. So let's see if we can figure this out. I'm going to get rid of the point light. I'm going to put it back to ambient material. And I'm going to go here, and we can see, okay, so there's no light, and it looks black because there's no light reflecting off of it. So again, now what I could do, I'm going to add directional light. So let's just out of curiosity, let me add a green directional light. Let me just give it a color and see what happens. Whoa, that is kind of nuts. So I don't know what sort of like weird by accident behavior this is, but the thing that I didn't give it is a direction. So for example, what if I want to say the light points in this direction? So that would be a positive along the x-axis and 0, 0. So let me say 1, 0, 0. That's a vector that pointing in this way in the direction to the right. There we go. So this is kind of more what I expected. Interestingly enough, it seems to be coming from the other side. Because 1, is that correct? You can see though at that moment, like it's really coming only from that one side. And I could add another directional light that's like red and put it, whoops. I could put it in the opposite direction. Right? So you can see these are two directional lights. Whenever this torus, you can see it's like green on one side, red on the other. 1, 0, 0 is right, it's correct. Why is that? I'm thinking of 1 pointing this way, but is the vector, like I'm saying, where it's coming from. So I'm pointing from the scene to an infinite location, out far, far away. So that's why. And so what I could probably do here is I could do a nice example of saying, let me look at the difference between mouse X and the center of the window. and mouse Y, and the center of the window. And I could give myself a red directional light from that direction. Now, it's working, but what did I miss here? Why is it so, it's so like unbelievably perfect? What did I miss here? Do I want to like give it a little bit of Z? What did I just do? Sound, okay. Why is this? Right? Oh, you know what it might be? Maybe I need to normalize those values. Okay, hold on. Just out of curiosity, just to be sure about this. Go back to the more recent version. Ooh, boy. Directional light is totally broken in the new version as well. Oh, no, no, no. Okay. I need to map it from 0 to 1. Okay. I need that vector to be a unit vector probably, right? So, and all right. Got it. Okay. Let me go back to that. So I've done something and I'm getting a weird artifact because of it. And the thing that I've done is that I have these like arbitrarily large values now for dx, dy. Before, when I just said, 1, 0, it's coming just from one direction. And notice that these values don't get higher than 1. So actually what I need probably is a unit vector, a vector that doesn't have a length greater than 1. And one way I could do that is I could make a vector in p5 with the create vector function that's dx, dy, 0. So this is a vector that has the x, y, and z direction. And then I could say v.normalize. And I think I might actually just be able to give that vector as the third argument. So let's see if this works. Yeah, so now you can see I can move my mouse around and change. My mouse is now the sun. Let's make it yellow. What's yellow? Red and green, right? So this would be basically like a simulation of the sun. Of course, the sun isn't really yellow. It's like a bright white. Let's forget about all this color stuff. Let's just say 255, 255, 255. And we can see here I have this bright white light coming from a particular direction. And you can see it's not going to change. It's just the direction. A point light would be different because I'm actually placing it like a point light I could actually put in the center and it would be reflecting off the center of the torus. But a directional light is just coming from a point sort of infinitely far away and pointing in that direction. Okay. Woo! Are you watching? If you have watched this video and you were learning something from it, you are a mensch, a true mensch here. Okay. I think that's everything. I think I have now gotten through all of the lights and all of the materials. So here's what I would like to ask of you. Think about an exercise could be, what about making like a little planetary simulation? What if you used a point light where there was actually like a moving sphere? So as the sphere, almost like it's a star and it's lighting other spheres around it or something. So try to create a scene that has different materials and different lights, point lights, directional lights, and see what type of effects you can create just with material and light alone. And in the next video, I'm going to look at something called a texture, which is really going to open up a lot of possibilities in how these three-dimensional shapes look. Okay, thanks. Whew. Oh my goodness. Well, I certainly have learned a lot about WebGL today. One thing that I'm curious about is the same bug. I hope someone's keeping track of these bugs for me. Is the same bug, right, true for directional light that we found for point light? You know, you could make the argument that P5 should internally normalize the vector for you. Yeah, same problem, right? Whichever is the second directional light takes over. But if I go back to the older version of P5, I can get both directional lights. So this is definitely something, it's 12:45. So what should I do? Quick straw poll here. Oh, this computer died. My Slack channel died. Oh, can I come back later? Oh, not enough time. I might have to just continue this stuff on Thursday. The question is, I was going to say, like, maybe I should just do the texture now and come back and do the coding challenge stuff on Thursday. Because the texture, I feel like, I was going to say, maybe I should just try to do the coding challenge. Because I have all the material, I have all the stuff to do the coding challenge. I don't need textures for it. And I have 15 minutes. I know which, I have a feeling, I just want to get the Slack chat back open. This computer died. I was going to say, I kind of know what people are going to, hold on, let me get this back up and running here. Textures now. Okay, do the challenge. All right. There's your straw poll, everybody. You got about 1 or 2 minutes to fill it out. All right, I didn't miss any. Oh, larger values make the math boost to saturation. That's interesting. The challenge, by the way, is there's no way I'm going to be able to do this in 15 minutes, though. That's why the challenge is this. Like, I think I could do this now without, this doesn't use textures. I mean, the lighting is sort of an interesting question. How to get these like different colors. Oh, and this uses isometric perspective. I didn't do, what I haven't done tutorial-wise is, well, first of all, I think it's an open question whether I need to just completely go back and do a do-over with the sort of lights and material tutorial. So I'm considering that. I'm going to wait till Mathieu, who does the video editing, kind of gives me some feedback there. So I need to do texture, and I need to do camera, and I do have that coding challenge. The thing about the coding challenge is I wanted to kind of cover simple harmonic motion in a basic video, which maybe that's what I'll do. Oh, there's so many. Yeah, you can use a video texture. Oh, I did miss a bunch of chat messages. Sorry. All right. Okay, so let's see. I have a feeling this is going to be obvious here, but oh yeah. So it's pretty, okay. Yeah, I'm just going to go with it. All right, let's do it. I'm going to do this. I'm going to run a little over time, but that's okay. And the challenge isn't that hard. Yeah, oh, okay. So everything is 10 times harder than you think it is. And you'll see, and especially for me, who's incapable of doing any of this stuff in a like quick and simple way. All right. All right, so Thursday I'm going to come back and do the rest of the WebGL stuff and possibly redo the materials and lights tutorial. And other, whatever. So let's see if I can do this challenge. Let me get set up here. Whoops. Okay. It's all squares that only move up and down. Okay, okay. All right. Okay, here we go. Twitter, bees and bombs. Whoops. People, Dave. Okay. And cube wave. All right, everybody. Alka, I know you're out there. Give me some tips in the chat as I go here. All right, this is my first coding challenge that I'm going to attempt in JavaScript using 3D rendering. I am currently working on a set of tutorials about WebGL in p5.js. I will link to those from this coding challenge's video description. But Bees and Bombs on Twitter, I highly recommend if you're interested in looking for like really geometric, algorithmic, mathematical illusion GIFs that will kind of blow your mind. Check out the Bees and Bombs Twitter feed and look at this. Oh yeah, look. Bees and Bombs is watching this right now. This is the GIF I'm going to try to recreate in p5.js using the WebGL renderer. Okay, so let's just see how this goes. I'm just going to get started. So first I'm actually going to just work in 2D because one thing that I need is just this nice, and I really need this in my life. Breathe in, breathe out. Breathe in, meditation. I'm very high strung. I really need to work on meditation. And this is actually a nice, calming, soothing GIF. So I need something that can give me that oscillating behavior and the sine function, simple harmonic motion, the swinging of a pendulum, the plucking of a guitar string. I do have some other video tutorials about that in processing that I will also link to from this video. So first, let's just make that happen in 2D. So what I'm going to do is I am going to have a variable. I'm going to call that variable angle. And I'm going to stick, I could add angle mode degrees to think in terms of degrees, but I'm just going to stick with radians. I'm going to say angle plus equals 0.1. Then what I'm going to do, and because once I get into WebGL mode, the center, 0, 0 in WebGL renderer is the center. I'm actually just going to quickly translate to the center because I want to just do this in 2D real quick. And let's say a rect mode center. And let's draw a rectangle. So I want to draw a rectangle which position is 0, 0, and its width is some arbitrary thing like 10, and it has some height. So if I were to say let h equal 100, I'm in the wrong place. We're going to do here. Okay, so one of these days I'm going to be able to move between these. Okay, so let's add a background. That's black, and let's add a fill. That is 255. Okay. Come on. There we go. There we go. So there's that rectangle. So what I want to see it now is breathe up and down, oscillate up and down. So the sine function is a function that will give me a value between -1 and 1. Time out for a second. I'm going to need to erase this. Where is my water bottle? This water bottle, that is. Oh, so sad, because when I continue the WebGL stuff, this will be gone, but that's fine. I will recreate this drawing. I've done that before. By the way, if this works out, it will feel like today was something of a success. Okay. If I were to graph the sine function, and the x-axis here I could think of as that angle that's increasing over time, I would see a curve like this. And that curve is going to oscillate between +1 and -1. So I could certainly use the map function to, and actually I probably will, I'll use the map function. The math is not that complicated, so I could take the result of the sine function as a variable value, and if that's between a range of -1 and 1, and I could map that range to between 0 and 100. Of course, I could just like multiply it by 50 and add 50, but let's use the map function. Why not? It's there in P5. So I could say H is now map sine of the angle, which has a range between -1 and 1, between 0 and 100. And what we should see now is this. So this is the behavior. I believe this is simple harmonic motion. There's so much that you could do with this, right? Think about layering these, all moving at different rates, offset from each other with different colors and sounds. You know, the world is your oyster now and what you could do with like simple harmonic motion. But here what I'm going to attempt to do is I'm going to attempt to try to create this. Now actually, I still think maybe I'm not ready for 3D. Because I think what I want to be able to know that I can do is put a bunch of these in a row, all oscillating offset. So can I make a 2D version of this first? Let's see if I can do that. So how am I going to do that? Well, I clearly need a loop. So let me say x equals 0, x is less than width, x plus equal, and let me go over by 10 pixels. And then let me draw each one of these rectangles at x. And I'm going to draw it with a width of 9 just so I can see it in between. So this, okay, so I forgot that I translated to the center. So, please go away, terminal. So what I want to do is start x at, I'll just say x minus width divided by 2 here. Whoops. What do I have wrong? Line 13, for let x equal 0, right? Okay. So there we go. Now I have a whole sequence of these oscillating, but obviously they're all oscillating together. And if you see here, they're all oscillating slightly offset from each other. So what do I need? I need an offset. So let's make a variable called offset, set it equal to 0, and I'm going to say, let's, I just want to, I'm going to say let A equal angle. I'm just going to break this up into multiple lines of code because I think that makes things a little simpler. So this is, this is the same thing. But now what I'm going to do is say angle plus offset. And then that offset is going to change for each one of those. And maybe let's just, I don't know, let's just try offsetting by the same amount that the angle is increasing. So they're all just one step ahead of the previous one. There we go. Now this has a totally different look to it. And it's actually like kind of, it looks like it's almost like this shape moving to the right. I mean, I don't know. I think we could start to play. I should probably like hook up some sliders here, like with different values. I'm going to get different sort of things like, but is this the right idea? It's so funny because it really looks like this thing moving. But what it is, and maybe if I make these thicker, like could I have less of that? Yeah, there we go. So you can see this, it's really an optical illusion, you know, by how I play with the size and where they're, and also like the x should start. So I need some more variables here. Let me make a variable called w, which is the width of each one of these. And I'm going to set that equal to 24. And I'm going to say w minus 2, just to give a little buffer between them. And then this is also where they start is x minus width divided by 2 plus w divided by 2. And let's have the offset. And let's have the offset just be perfect again. And we can see, there we go. So what you can see, this is all the, now in the bees and bombs GIF, there certainly is this sense of the center going up and down, rippling out to the outside. So I might need to think about like how, what angles I'm starting, where the offset is and that sort of thing. But I think this is close enough. Okay. I think I can move to 3D now. So let's try moving this to 3D. Okay, so a few things I want to do. First thing first, let's just add WebGL, and let's just take out this translate. Dare I say, if WebGL mode works the way I hope and dream it will work, I'm actually going to see the same exact thing. Right? All I did was change the renderer. I'm still drawing everything as 2D shapes. I just changed the renderer, and now I don't have to translate because by default, the renderer thinks the center is the center of the canvas is 0, 0. All right, so I'm not seeing the shapes. Oops. Hold on. First of all, this terminal thing is driving me crazy. So what? Let's just see. Let me change the background here. Yeah. Oh, whoa. First of all, look how slow this is. It's crazy how slow it is. And the reason why I wasn't getting the color proper is because, well, I really shouldn't be using the rectangle function here in 3D. So let's see if we can figure out, let's try to make this a little better right now. First of all, let me put boxes in this spot. So what I'm going to do is I'm going to say push, I'm going to add push, and I'm going to add pop. And what I'm going to do is I'm going to just translate by the x value, 0, 0. And instead of drawing a rectangle, I'm going to draw a box of that size. So let's see what I get. Okay. Oh, and incidentally, now what I need to do is I need to translate x minus width divided by 2. So these are all boxes. These are 3D boxes. You can't see that they're 3D because I'm just seeing them from the side, but you'll have to bear with me here. Just to prove that they're 3D, what might be worth doing is just saying something like rotate x by that angle. So that angle that's affecting the side. So we can see that they're there. I'm going to leave that in there just so that we can see this like slow rotation of the scene. And I'll even slow it down by like a quarter. So what I want to do now is, let's see if I can, how do I affect the heights only of those boxes? So the box has a width, a height, and a depth. So I want, the depth, I'm just going to have BW as well. So the width and the depth, which is along the z-axis, and the h is the height. So let's try doing that. There we go. Now they're spinning. Whoa, look at this. I think I'm getting somewhere. Wow, this is kind of crazy looking. Oh my goodness. Let me take out that spinning. Let me move the whole thing down a little bit. And let me zoom out from it a little bit. So I'm going to translate like everything down like 25 pixels and out like 50 pixels. So we're kind of like zoomed away from it. I want to see it from above a little bit. So if I translate it down even further, I guess I need to think about maybe the camera, or I could like sort of like rotate everything by like a slight amount. So I want to rotate along the x-axis by like 45 degrees or something. Oh no, I want to just say rotate x. And I want to do it the other direction. There we go. So I just wanted to get some view on it that somewhat resembles, sorry, I lost this particular view. Now one thing you'll notice, have you ever played the video game Qbert? Well, what this looks like to me, I believe, is something called isometric perspective. Or no. Oh, yeah, or orthographic perspective. Let's look at the p5.js reference for a second. Reference. Perspective, yeah, perspective. Perspective is a function that kind of says like, hey, this is where this is what the camera can see. This is its view of the world. And actually what I want is this function ortho, which sets up, now there's not a lot of documentation here, but it sets up, so let me see if I can like orthographic perspective. Let me do an image search. So this is perfect. So you can see this is a really nice image here to kind of demonstrate the difference. Perspective projection has this realistic view of sort of distance and of all of this idea of like perspective of drawing, if you were trying to learn to draw in perspective of how the lines come together to a point. Whereas orthographic projection, so perspective is the wrong word. I'm saying orthographic perspective, that's not right. The idea here is the projection creates this highly uniform look. And the video game Q*bert is probably the most famous sort of example of this kind of orthographic projection. So I believe all I need to do is say at the beginning ortho, and then what I want to give it is a bounding box of what I want it to see. Left, right, bottom, top, near, far. So I'm going to say left, and you know what? I'm going to just have the numbers hard-coded here. Left, right, bottom, top, and you know what? I'm just going to have the Z be the same. I think this should work. And, oops. All right. Is the Y the other direction? No. Near, far? Isometric is orthographic. Okay. All right, what am I? This is time out here for a second. Just type ortho. Oh, do I not need to give it the arguments? Will it do something nice and default for me? Whoa! What has happened? No vanishing point. Is that the way to describe it? With? All right, let's try. Getting some nice suggestions. Thank you, artwork. Let's try this. My version doesn't use arguments. Dare it be like a bug in the newer, what version were you using, Alka, of I wonder if I need to go revert to an older version of p5.js. Oh, it's 10 after 1. This is bad. 0.5.6. I wonder if ortho is broken. I could do the whole thing without ortho. I felt that was orthographic projection. I felt like that was kind of important. Let's try reverting to an older version of the P5 library. Okay. So add this to the list of things that are broken in the newer version of P5. Okay, hold on. We're gonna have to back up in this coding challenge. Yeah. And why did I lose? I wonder if basic material is what I needed to use. The problem is now I've lost, or is that just because? doesn't match because something else changed. I'm going to do this. Yeah. And hold on. Also, it changed. The direction of rotation changed. Because this is what I had before, right? Or does ortho change that? Right? This is kind of like what it looked like. It should be quarter pi. Yeah. Works in 0.7, 0.8. It is broken in 1.6. So let's try to go to version 14. Maybe we'll get other stuff more close to what I had. Okay. So something changed. Something changed somewhere. Oh, this is... All right, close enough. Let's get rid of the normal material. All right, close enough. Okay, let me keep going. So let's add orthographic projection. So I can give it like a clipping plane or a sort of, it's called a frustum, like the bounding box of what I want to be able to see with orthographic projection or isometric projection. But I think by default, if I just say ortho, it's going to change. And let me hit refresh. And whoops, let me put, okay, so yeah, so you can see now it looks very flat. Now I need to be able to start to see the different sides of different colors. So let me see if I can add maybe at least some directional lighting. Maybe let's see if I can just add some lighting from the top. Let me just say directional light 255. And let me add the light from the top. So 255, 255, 255. And then I want the light to point down, which is 0, -1, comma 0. So let's see if this gives us at least some shading. And what if do I probably still have fill in here? Right. So I need to, fill is going to take over. I need to just give it ambient material. Ambient material will allow the box to be affected by the light. There we go. And I can make the, oops, and I want the light to be white. And maybe I can make the background black. Yeah, so I'm not really getting a lot of nuance here in terms of, but let's make the box's width a little less, so there's some space. Okay, and I want to be able to look at it now. Maybe I should just give it ambient light. I could give the different sides. I'm lost now. All right. So how come I am not? Let me try rotating. How can I see the tops? How can I see this shape? I need to figure this out. Oh, ambient light, by the way. So I don't want to use ambient light. I could try a point light. I'm thinking, maybe I'm going to get a suggestion from the chat. I just want to, let me give it normal material. So normal material is a useful material for debugging because it just gives it an RGB colors to all the different vertices of the shape based on their X, Y, and Z values. So let me give it normal material. And this now should allow me to see, okay. Okay. So Alka in the chat is giving me an excellent suggestion for how to, so orthographic, isometric view of orthographic projection. That's what I'm looking for, right? So what I need to do, maybe I can find some documentation of this, but I'm just going to type what Alka just sent me and see if this works. And then I'm going to say rotate y, quarter pi. I knew I shouldn't have tried this with a fixed amount of time that I have. What did I do here? I need another. Hold on, let's pause for a second. Let's edit this part out. Whoa. What? The problem is all these different, I feel like there's all these weird bugs in P5. So let's go back to like a much earlier version. And let's get rid of this translate and get rid of this rotate. There we go. That looks promising. Yeah, okay, so hold on everybody. I'm just thinking this through here for a second, then I'm going to come back to it. What I want to do is, let's try to get back to here. Yeah, same. So that's interesting. I guess I'm going beyond the clipping plane there. Is that why? It's getting far clipped. So I'm going to far clipped. So that's probably something that I can do here. Something like this. Oh, crazy. Oh, I flipped it. There we go. And if I make the background 100, there we go. All right, now we're getting somewhere. Now, is this actually? Yes, that is totally right. All right. Okay, hold on, I gotta back out of this. Because I'm gonna back out of this. Thank you, Alka. So here's the thing. Okay, we're getting close. So what I would like to do is isometric view. Isometric projection. Okay, I know I really would love to donate right now, but so there must be some documentation of that somewhere. I just want to see those angles that you sent me, which is rotate x by atan quarter pi. (45 degrees on the x-axis. Second rotation to bring this arctangent of 1 divided by square root of 2. Arctangent of 1 divided by square root of 2. Plus or minus 45 degrees along the vertical axis, followed by rotation of approximately arcsine or arctan of 1 divided by square root of 2. Okay. Arctan. So you did the cosine of quarter pi instead of 1 divided by square root of 2 because that's related to the magic angle. Okay, so I'm going to refer to this. Okay, everybody, let's go back here. All right, so actually, I think this is doing what I wanted to do now. I'm seeing the orthographic projection, and the normal material is giving me RGB colors for all the vertices, but let me make the background 100 just so I can really see that. There we go. So this is actually, I'm now looking at the correct thing, but I'm not actually looking at isometric view. Here's the thing though, I'm gonna leave this like this right now. Let's try to nest this loop, and let's have a bunch of these. Okay. So, and I can actually, I'm going to take, so let's have a bunch. So what I'm going to do now is also add an inner loop. Let's add an outer loop. Let's add an outer loop for y. And what I'm going to do with y now is translate y minus height divided by 2. Okay? And let's make the depth also a little bit smaller just to have some spacing there. So, okay, x is not defined where? What happened? X is not defined as sketch line 22. Oh, this has to be y. Thank you. Okay. All right, now, is this doing what I want it to do? Is it doing what I want it to do and I just a weird sort of view of it? So let's try to start altering. I want to see what's going on here a little bit. So what I'm going to do actually is rotate x by that angle. Whoa, I've really freaked it out. Let me take this out. Let me make this just fixed. So what is going on? For every x, for every y, draw a little box. Okay. Oh, they're all just right next to each other in a line. Oh, because I don't want to go along the y. People are probably talking about, I need to use z. Of course, z. Of course, the z-plane is what is allowing me to create this grid of them. Y is what's moving up and down. So, I apologize for this. So I'm actually going to do z. I'll just leave height. I'm going to change the variable to z though, just because I feel like it's going to be confusing. And now, yeah, we see now I have this grid of them, and I'm kind of spinning around it in a weird sort of way. And what I'm going to do here is, and I actually don't need this offset to subtract backwards, I don't think. Oh, actually, no, that would be good to keep that in there. Okay, what I want to do now, hold on everybody, is let me take this out. Okay, now there's this plane of them. Let me put h back in. And interestingly enough, what's going on here? Sine, angle equals angle plus offset. So I want the offset to happen right now just per row. Okay, so I see this whole row going up and down. All right, now here's the thing. I need to be able to look at this. I probably should have done this before. I really should have done this before. But if I look at isometric perspective, actually to see isometric perspective, what I need to do is first rotate by 45 degrees about the vertical axis, which is x. So I'm going to, let's get rid of this translate, which I think is, actually we're going to leave that in there. I don't need rect mode center. I'm going to rotate x minus a quarter pi, which is 45 degrees. Let's see what that looks like. All right. That's kind of interesting. What's going on here? Now, I'm kind of looking at it from this weird like top view. I want to turn it. So the next thing I want to do is rotate by y of, and let's look at this. Arc sine or arc tan. So I could do one of these. So I'm going to do arc tan of 1 divided by the square root of 2. And I should make this a constant somewhere that I save. Let's call this magic angle. And say, let's call this, I'm just going to call this MA for magic angle. MA equals a tan of square root of 1 divided by square root of 2. So let's now rotate y by that. Thank you, Alka, for having suggested this. There we go. Ooh. Okay, we're in good shape here. Look, I'm seeing this now. Here's the thing. I've got a clipping plane issue. Like I'm not actually able to see the whole thing. So let's deal with that. I can, with ortho, I can say this is the range of what I want to be able to see. So I want to see between negative 200 and 200, between negative 200 and 200 on the y, and then I just want to be able to see like a lot along the z. Okay, that's everything. And maybe I should zoom out a little bit, just so it's a little further away from me. Hold on, let's get rid of this translate. And let's say 0 to 500. There we go. I think then, all right. Oh, it's like I've turned it over also. Boy, what a mess. So maybe this should be 200 to negative 200. There we go. Ah, kind of getting somewhere. Look at this. Kind of getting somewhere. Okay. Now I need to deal with my clipping planes, and I actually think it might be getting clipped in all, whoops. There we go. I want to look at it from further away, so I'm going to create that. So that was too much. 300, let's try 300, and boy, I could make these variables would really help. There we go. Okay, so I'm seeing this thing now. It's kind of like a little bit off weirdly. Okay, it's a little bit off weirdly. And so what am I missing? Does this just need to be, is that the z that's getting clipped? Yeah. Okay, so now I see the whole thing. I see the whole shape. Now what I need to do is figure out the offset. And what I think I could do, if I think about this, is the offset is not a value related to along the x or along the y, but how far it is from the center. So what if I were to come back here and inside my loop have some kind of distance value, be the distance between x and z and not 0, 0, but width divided by 2 and height divided by 2. That's how far they are. I feel like I should actually have just translated this whole thing offset. It would have made it easier, but because I have all this like offsetting. So that's the distance. And instead of having this offset like increase, what if I just say offset equals map that distance? Now what's the range? I probably should figure out what the maximum distance is. The maximum distance is max d is going to be the distance between the center and 200, 200 really. Right? That's kind of like the maximum distance. So d has a range between 0 and max d. And I want that offset, I'm just going to make up something between negative 1 and 1. Like I want an angular offset for each of those. Now let's look at this. Ooh, it's so slow, but this is the right idea, right? So let's make this, let's try to make this run a little faster, boy P5. So there's probably a lot of optimization that needs to be done because we certainly can do this in WebGL. They're all going to remake this. So a couple things I want to do. One is let me make this, let me make them bigger. What is the slowdown? Okay, that's a little bit better. Now, I want this, what it's mapping to in terms of the height to be a lot taller. Yeah, so I need to do some work with like pre-saving all the geometry, but that I'm getting, Alka's making a good suggestion. Okay, so I have to go though, this challenge is over. Let's have the offset be more, twice as much. There we go. Hey, look at this. Pretty close, right? Pretty close. So what have I not done? One is I really need to deal with optimizing this. Two, I really probably want to be more thoughtful about the perspective here. Like this is nicer, like kind of how it's centered and zoomed out, the color of the different sides. I'm being told, breaking news, I'm being told that first of all, that this computer has totally died. Probably, you know what's actually bad is that I don't have it plugged in. Wait, hold on, let me go back to here. Okay, let's look at this. So the direction, am I getting the direction wrong? So what could I do really quickly to optimize this? Put the push and pop in the outer loop. I've really killed my computer. This video should have ended. It is reversed because y is the vertical axis, not the x. You should change it. No, I definitely want to change that. There we go. Okay, so wait. I'm trying to understand. Into out is the original. I'm having trouble seeing the difference. Oh, you know what also? There's a couple things. Yeah, it's the shrinking to 0, which is a problem. Yeah. Okay, so first of all, how can I pre-compute? Is it really just pre-computing, like doing a lookup table of the sign values? Is the normal material like making it really slow? You would think normal material would be easy for it to do. It's clearly accumulating over time. Yeah. The fraction of the period, like if each cube was a particle. The wave seems to have minimal heights. The top doesn't touch the bottom. It's in reverse. I might have to come back. I'm going to come back later today to deal with this. It just has a position and a known distance. Oh, the distance. But I don't understand how this math could really be causing so much slowdown, right? It seems to me that there's a rendering thing going on here. You know, if I floor the height values, does that like help it? It's also over time. Oh, interesting. Look at that. Flooring the height values completely fixed the performance, I think. And you can see going to 0 is a problem. Something is wrong with the magic angle, yeah. That's the same. Well, I definitely fixed the performance issue. Okay, hold on. So let me... Or I don't know what I did to... So one reason it's running so slow, I think, is actually it's kind of unhappy with having these floating point numbers for the height of the box. So I think if I change this to floor the values, but I am getting some weird artifacts here. And that's actually, if we look at the bees and bombs, you'll see that it doesn't actually go to 0. It goes between some set of values. So it goes between maybe like 100 and 300. Let's try that. Whoops. There we go. So that is much more like, now could I zoom out on this more? So one way I could do that is by translating. I don't know if this makes the most sense to do. Let me zoom out a little bit. No, you know what I need to do is just change the, I think I need to be more thoughtful about the orthographic view. Okay, so I zoomed out a little bit and make more, let me make more cubes now. So let me change this back to like 24. There we go. How am I doing? So this is moving faster, and that offset is even more. So let me map the offset. And actually, yeah, -3. Let me just, I mean, I probably should be thoughtful about this and have that offset be like, you know, some actual like angle. Oh, but that's half pi. Actually, let me just have it between -pi and pi. Let's try that. There we go. This is starting to look good. And now, okay, and now let me have it go a little bit faster. Hold on. Dave, are you still watching? How did I do? So here's the thing. Here's what's missing. And I'm going to leave as a challenge for you, the viewer. Number one is I've got the perspective slightly off here. Something's slightly wrong, right? I don't have my angle exactly right. Right? Why is there this weird kind of like diagonal there? It's also in reverse. Everyone's telling me it's in reverse, so this has got to be an easy way to fix that. Oh yeah. Ooh, that's kind of nice. It's a little bit too fast. So it's in reverse. I fixed that. The angle is off. Like, it's got to be the second angle, right? Right, that's right. Something is wrong with this angle. In fact, cosine what's it the equivalent of? This 1 divided by square root of true is actually the equivalent of cosine of 45 degrees or quarter pi. That's just going to get me the same. That's going to be the same though. So I don't know. So something is wrong. Delete the distance and lower the height even further. Everyone's giving me good suggestions. I have to go. I'm like so late for something right now. And I didn't even eat lunch. So, okay, I'm going to come back later today. Okay. Okay, I didn't get all the way there, but I got pretty close. And so the challenge for you, the viewer, is to fix my mistakes. Something about the perspective is off. I probably need to think about, you know, the speed, and I might like to color or use lighting to make it more beautiful. What other types of 3D shapes? Oh, rotate X after rotate Y. Did I just do this in the wrong order? Whoa, that's kind of cool. Something different. Okay, I gotta go. Thanks for watching this coding challenge, and I'll see you all later. The sound is dying. Okay, delete the gap between the boxes. Okay, I have to stop. Okay, I have to go. I'm going to try to come back and, I don't know, deal with this later. But I'm very, very late. I've killed this computer. And so this stream is going to end like really abruptly. I'm letting you know that right now. I'm going to try to come back for just like a half an hour later today. Okay, bye everybody.